Good morning dear students. Yesterday we discussed about the brief introduction of our subject instrumentation. Now you can see the first unit. The first unit is signals and their representation. So in that the first topic is measuring system. So before going to the measuring system, you need to know a few definitions very well. So those already came in your measuring system subject. So now we can discuss those definitions as well. So what is the necessity of a measuring system? So where we can use measuring system? So what is the necessity of the measuring system in our regular life? So let us take a person is. So without using any measuring instrument, otherwise without using any quantity or without using any real number, how we can able to identify the age of a person? Likewise height and weight. So all these things, if you want to know, we need to tell with weight or height or age with certain quantity or certain real number. So without knowing that, it is not possible to tell weight or height or age in an accurate way or precise way. Otherwise we have to compare the age of one person with another person, but that is not accurate and precise. So this is the need of a measuring system in our regular life. So without a measuring system, that means without knowing the real quantity of anything, we cannot express that in a real way, accurate way, in precise way. So this is the necessity of the measuring system. So what is the instrumentation? So instrumentation is the advanced subject after the measuring system. So before going to the instrumentation, we have to know a few basic definitions. So the first one is measurement. So what is meant by measurement? So process of identifying the quantity. Process of identifying the quantity is nothing but measurement. So let us take, if you want to find the voltage from a electrical circuit, what you can do? Simply you can take the probes of a voltmeter, you can connect across that electrical circuit so that you can able to identify the voltage. So in this, what you are doing? Connecting as well as taking, and the internal process of that voltmeter can be called, all this called as measurement. So this process can be called as measurement. So what is meant by measuring? So the quantity which is to be identified can be called as measured. It's the quantity to be measured, which is to be identified. So here in the previous case, we are taking voltage. So voltage is the quantity which is to be identified now. So it can be called as measured. So next one is measuring system. The system which identifies the quantity of measured by the process of measurement. By using the measurement process, if you can able to identify a quantity, that system can be called as measuring system. Here in the previous case, if you are giving the probes to the electrical circuit as well as the voltmeter, so here the voltmeter is the measuring system. So then what is meant by an instrument? So instrument, the device that control or measure the quantity. So there is a lot of difference between the instrument and measuring system. So always all measuring systems are instruments, but in all instruments are not the measuring systems. How we can justify this? So let us take an audio device which can able to produce audio. So here the device that control the quantity. So it can able to control the audio. So it is an instrument, but it was not measuring anything. It was not measuring anything. So let us take a voltmeter. It can able to identify. So that means measure the quantity. Control or measure the quantity. It can able to identify voltage. It is also an instrument. It is also a measuring device. So measuring system is always an instrument, but the instrument is always not a measuring system. So what is meant by instrumentation? It is the art or science of measure or control of process variable or quantity. Simply the study of instruments. So that means the study of the course of instrument can be called as instrumentation. It is the subject. So the art or science of measuring or controlling of a process variable can be called as instrumentation. Simply, it is the course of knowing instrument, measuring system, all these things. So it is a subject. So this is about the basic definitions in our instrumentation. So now we have to know that what is measurement and what is measurand and what is measuring system and instrument and instrumentation. So standards of measuring system. So there will be two standards here. So before going to that standards, you need to know what is meant by calibration. So why? Because in the standards we have to go for calibration. So what is meant by calibration? So it is the process of comparing the quantity with standards. Process of comparing the quantity with standards. So let us take a resistor. So if you want to measure the resistance, you can tell some 120 ohms and 100 ohms as per its value. So that means how we are telling it is 100 ohms, how we are telling it was 150 ohms or 120 ohms. So that means somebody has taken some amount of resistance can be considered as 1 ohm. So that amount we can fix as it 1 ohm. If that amount of resistance is 100 times, then we can call it as 100 ohms. If it is 150 times, we can call it as 150 ohms. So this is nothing but calibration. So process of the comparing the standard values with the existed values. So we are having a resistor is nothing but the existed value. Some ohm is defined by somebody is the standard value. So we are comparing this with that standard value can be called as calibration. So why this calibration is studied, we are knowing now is because of standards. So there are two types of standards. The first one is absolute or primary standard instruments and the second one is secondary standard instruments. So what is meant by absolute standard instruments? These are the instruments we can use only for calibration purpose, not for using purpose. So these will be in specific libraries or labs. So these are instruments which can use only for calibration. So why these are using for calibration means we have to know the secondary standard instruments. The secondary standard instruments can be used in laboratories. Suppose let us take our voltmeter or ammeter. So these are the secondary standard instruments. So why we are using these instruments for identifying voltage as well as current. But after some time these instruments can reduce their accuracy and precision. Why? Why? Because it has to calibrate for every year. Otherwise it cannot able to show the exact value. So what is meant by absolute here means, so if you can use a device, it can lose its accuracy and precision. So what they can do means absolute devices they can maintain in a particular library with certain temperatures, so that they can always be the standard units. So always we have to calibrate the secondary instruments with the absolute instruments. Thereafter we can able to identify the exact values by using secondary instruments in the laboratories. So what we have to know from here means absolute instruments can be used only for calibration of secondary instruments. The secondary instruments can be used for laboratory purpose. So if you can use absolute instruments in the laboratories, what will happen? It can lose its accuracy and precision. If absolute standards also lose their accuracy and precision, so with whom we can be able to calibrate the secondary instruments? So it is not possible. So it is not possible. So absolute standard instruments can always will be in certain libraries with certain temperature. With certain temperature. The secondary standard instruments we can use in our laboratories. All voltmeters, ammeters and power meters, all these are secondary standard instruments. So what is the basic measuring system? So there will be two types in basic measuring system. So the first one you know that analog measuring system, and the second one you know that digital measuring system. So what will be the difference between these two? So digital is more accurate when comparing to the analog measuring system. So analog measuring system can able to show the value with a moving device. We can use a moving coil or moving iron instrument for that. So digital instrument can able to show a value with a digital display. So when comparing to moving device, the digital device will be more accurate because there will be certain points. So you cannot able to identify in between two. If the needle is in between two, you cannot able to identify the exact value. But here in this digital measuring system, we can able to identify the exact value by the display. So that is the main difference. So how the analog measuring systems looks like? The basic. So the first one is analog measuring system. So first measurement. So I already told you measurement is nothing but the quantity which is to be measured. So the measurement will be connected to the primary sensing element. So let us take a voltmeter an example. So now we have to measure the voltage. So now it was the across voltage was connected to primary sensing element. Likewise the probes with our voltmeter knobs. So then what will happen is that knobs will be connected to the primary sensing element. So what is the function of primary sensing element? So from an electrical circuit you can have identify so many things: voltage, current and power. So here the voltmeter, but the voltmeter has to take only the voltage signal from the electrical circuit. So what is the function of primary sensing element is it has to take only the voltage signal from the measurement. Then only the voltmeter can identify the voltage. So what is the function of primary sensing element? It need to take the signal of measurement only, not other quantities like current and power. So now it was connected to intermediate means. So if you want to know this, the exact meaning of this intermediate means, you have to go for the next block. So the next block is data manipulation element. So what is the function of data manipulation element? So data manipulation element can able to calculate the signal that is provided by primary sensing element. So it can able to calculate the signal. So primary sensing element here in this case voltmeter is the example. So it was collected the voltage signal. So that signal can be manipulated. That means calculated by data manipulation element. So what intermediate means can do? So the signal that was coming from primary sensing element cannot be understandable for the data manipulation element. So what it will do, it can able to convert that voltage signal as an understandable signal to the data manipulation element. So the next one what have to give? So after identifying the signal voltage, we need to show it. So next one is scale. So the analog scale will be like this. There will be a needle. So as per the needle movement, we can able to identify the measurement quantity. So this is the analog measuring system, a basic analog measuring system. So what it contains basically primary sensing element, intermediate means in some textbooks it will be amplifier. In some textbooks it will be data processing element. So likewise. So it can be intermediate means in some textbooks. So whatever maybe the term you can use it, no problem. So primary sensing element, intermediate means, and data manipulation element and the scale. These are the four elements which are required to measure any quantity. So this is about the main analog measuring system. The next one is digital measuring system. What might be the difference between these two? So after data manipulation system, the scale is identifying it. So now what we have to add? So let us see. So again the measurement, and the measurement will be connected to the primary sensing element, and the function of primary sensing element is we need to identify the signal that is to be measured, and thereafter same intermediate means it can able to convert the primary sensing element signal as an understandable signal to the data manipulation element, So what is the data manipulation element can do? It can able to calculate the value of the signal that was provided by primary sensing element, and thereafter what we have to do? A to D converter. So now we got the analog signal, but that is cannot display directly. So that we have to convert that analog signal into a digital signal, so that we have to use A to D converter. So thereafter a digital display. So here based on the digits. So here in this case there are 4 digits. So if there are 6 digits, the device will be more accurate. So based on the display, it will be the more accurate. That means based on the data manipulation element actually. So if the data manipulation element can able to calculate the value up to 6 digits, then the display will be 6 digits. If the data manipulation element can able to calculate up to the 4 digits, it will be 4. If it is 3, the display will be 3 digits. So coming to the advantages of digital measuring system over analog measuring system, what might be the advantages? The first thing is more accuracy and more precise. And the next one is it is not possible to identify the exact value by using the needles, but here it is possible with the digital display. And one more thing is parallax errors at analog measuring system. But in the case of digital measuring system, we can able to identify the value exactly without any parallax error. So these are the basic advantages, you know that already. And the next one is block diagram of a measuring system. What will be the block diagram means? Here the inner parts of the, let us take the voltmeter. What will be the inner parts of the voltmeter? So with the blocks. So as we know, the first one is the measurement, which is need to be connected to the primary sensing element. So generally the primary sensing element is a transducer. So transducer I already told you in the previous class. So what is meant by a transducer? A transducer is a device which can able to convert one form of energy into another form of energy. So here it can able to identify the signal that is from the measurement, so that it can able to convert the signal to the next block, understandable signal to the next block. So data conversion element. So there we are using the term intermediate, means here we use the term data conversion element. So that means it can able to convert the primary sensing element to the signal as an understandable signal to the next block. So data conversion element. So next one is data manipulation element. So manipulation in the sense calculation. So it can able to calculate the signal that is provided by the transducer. Transducer in the sense primary sensing element. So different transducers can be used for different types of measurement purposes. So the next one is data transmission element. So why the data transmission element? If you want to send the data that was calculated by this measuring system to the long distances, so we have to use data transmission element. So likewise, so in news you can see the temperatures. So daily temperatures and daily weather news. All these are the measurement news. So those can be identified at the actual measuring system where they are established. So now how we are seeing by using data transmission element. So here the TV network is the data transmission element. So this data transmission element can able to use to send the signal of that is coming from data manipulation element to the long distances. So the next one is data processing element. So after transmission, it has to be processed to understand the display. So why? Because after data transmission, it will be cooperated with the higher frequency signal, which can be called as carrier. So that means without cooperating the higher frequency signal, it cannot travel until the long distances. So what data processing element can do? It can remove the carrier signal from the data manipulation element signal. After that, it can use the data manipulation element signal to the display. So now the display can display the value that was measured by measurement. So next one. So data recording element. So this recording element can be used for next uses. That means if you want to see, if you identify the temperature in the morning, so now we have to give that temperature in the evening uses. So this data recording element can record the temperatures and it will show when if you want. So again, the signal that is coming from the data recording element will not be understandable to the screen. So what we have to use again? We need to use the data processing element and as well as data storage element. So the storage element can store the recording elements and the storage element also contains the data processing element. So this data processing element can be converts the storage element signal into the understandable signal to the digital display. So this is the way. So these two blocks, that means data recording element as well as data storage element, can able to use only for the purpose of storing. So whenever you want to use, whenever you want to know the value of measurement that was measured by another time, we can see by using these two blocks. So this is about the basic block diagram of measuring system. So the next topic is performance characteristics. So the performance characteristics of an instrument can be classified as two types. The first one is static characteristics and the second one is dynamic characteristics. Why we need to know these characteristics of an instrument? So an instrument can be used for specific purpose of measuring of measurement. So if you want to find the voltage, there must be a voltmeter. So the voltmeter must be show the accurate voltage even in all environmental conditions. So that we have to take a transducer that can able to give an accurate, precise signal of at any time even the environmental conditions are changing. So that we have to select a particular transducer that will be not affected by the environmental changes as well as temperature changes. So here we need to know the characteristics of that transducers. So at what range that transducer can be more accurate and precise. So there are two types of characteristics. Those are static and dynamic characteristics. Let us see about the static characteristics. So these static characteristics of an instrument need to consider at the time of static calibration. It can be done with absolute and secondary standards. So what is the meaning of this sentence is, so we need to consider the static characteristics at the time of static calibration. So if you want to make an voltmeter, so we have to give the voltage values as per the absolute standards. So that we need to calibrate your device in front of absolute standards. In front of absolute standards. Then only that voltage will show the accurate values. So at that time we need to consider static characteristics of that voltmeter. So what are those static characteristics? So there are 19 different types of static characteristics available. So we can see those each and everything in detail. No problem. So the first one is accuracy and precision. And the second one is static error. Third one is static correction. Fourth one, uncertainty, repeatability, reproducibility, stability, zero stability, resolution, sensitivity, responsiveness, linearity, drift, threshold, deadband, span and range, live zero, scale readability, input and output impedance. These are the 19 factors we need to consider if you want to check static characteristics of an instrument. So in the next video we can see each and everything in detail. So in the present class, first we can see what is accuracy and precision. So accuracy, it is the nearness or closest of the indicated value to the true value of the quantity to be measured. So what is the meaning of this sentence? So accuracy means it is the nearest value to the value which is to be measured. So suppose let us take an absolute value. For absolute means the standard value of that instrument. So if an instrument is identifying the nearest value to the absolute value, then that instrument is more accurate. So this is the degree of accuracy of that instrument. Then what is meant by precision? So precision, it is the nearness or closest of indicated value to the indicated value of different successive measurements of the quantity to be measured. Suppose if there is an voltmeter, so if you identify the same voltage for many times, even identifying for many times it was giving the same value, then it was more precise. So this is the definition of precise, the nearness or closest value of indicated value to the indicated value of different successive measurements of the quantity to be measured. So accuracy means it must be nearest to the true value of the absolute standard. But precise means it must be nearest to the different successive measurements. So this is the difference between the accuracy and precision. Let us see how this will be differ with the graphical representation by taking an example. So let us take, this is a target. We can use these targets in archery. So let us assume this is target A and this is another target B. So this is the person which is hitting target A and he is the person who is hitting the target B. So these are two persons which are hitting a target for 5 times. Can you please tell me which one is more accurate and which one is more precise? So now the A is hitting the target, then C. So first time he was hit at that place, this is at second time, and third time, fourth time, and fifth time. So this is the result of person A. And now coming to the person B, he was hit the first target at that place. So this is second time, third time, fourth time, and fifth time. And tell me who is more accurate and who is more precise. So the person A, he was hit 2 times in the nearest to the target. That means the inner point, the middle point can be considered as nearest target, which can be considered here as 12. So those two, for the person A, he hit 2 times in the middle circle. So that means he is nearest to the true value. So that means he is accurate at that 2 times. But what about the precision of him? He was hit for 5 times. There are a lot of difference between each. Successive operation. So there will be a lot of difference between the first one and second one, third one and fifth one. But see the person B, he was not hitting the middle, but see that always the distance between the true value and the hitter value is the same. That means he is more precise. Of course, he was not accurate because he was not hitting the true value. So if you can able to combine this accuracy as well as precision to a single person, he can able to hit the true value always. So instrument must be accurate and precise. So then only it can able to identify the same value all the times. So this is about today's class. We can see the next bit. That means static error and static correction, all those things in the next class. Thank you, dear students.